Good morning, students. Today we are going to learn a linear programming problem with graphical method. How to find the solution of a linear programming problem using graphical method. So what is the question here? Maximize z equal to 3x1 plus 4x2. This is the objective function subject to the constraints x1 plus x2 less than or equal to 450, 2x1 plus x2 less than or equal to 600, x1 comma x2 greater than or equal to 0 using graphical method. Graphical method we usually use for problems with two decision variables. Why we don't use more than two decision variables is the complexity of their visual representation. So problems with more than two decision variables we introduce simplex method. So see the solution now. How to do the solution? Take the first constraint and set the inequality. Set the inequality to equality. So here the first constraint is x1 plus x2 less than or equal to 450. So put the inequality to equality. So x1 plus x2 equal to 450. So find the points. Put x1 is 0, x2 is 450. Like that, put x2 equal to 0, you will get the point for x1. So these are the 2 points for this line to plot on the graph. Like that, take second constraint and similarly set the inequality to equality. So 2x1 plus x2 equal to 600. Find the points for this line to plot on the graph. So put x1 is 0, x2 is 600. So put x2 equal to 0, so x1 is 300. So these are the 2 points to put in the graph. So now how to draw the graph? So here, as I told you, take the x-axis, okay, and y-axis, and this is the origin, and take the scale according to your points. You can choose any scale that is with a difference of 50, 10, 100, depends on the points. So here 0, 450, 450, 0, 600, 300. So these are the points I took with a difference of 100. So 100, 200 up to 500, and also here. Okay. Now the first point we will plot on the graph, that is x1 plus x2 equal to 450. This is the line. So what are the points for this? 450, see the 0, 450, 450, 0. So 450, 0 lies on x-axis. So this will be the point. And here 0, 450 lies on y-axis. So this is the point. So draw the line by joining these 2 points. So I named it as A and B. Okay. Now this line is x1 plus x2 equal to 450. So any point lying on or below this line will satisfy the constraint x1 plus x2 less than or equal to 450. So any point lying on or below this line satisfies the constraint of x1 plus x2 less than or equal to 450. So this is the region of this line. So this is the region I indicated. So you indicate like this. Then the second point, see 0, 600, 300, 0. So 300, 0 lies on, see here, x-axis. And another point is 0, 600. So this lies here. So you can now draw the line for this. Okay, draw the line like this. So the intersection point you can find. If it is a graph, it will be more clear. So this is the intersection point. So give the name C and here D. So you can say this is E. So what is this line? 2x1 plus x2 equal to 600. Now with the vertical lines you just represent the area, cover this region. So any point lying below this line, 2x1 plus x2 less equal to 600 satisfies the criteria of 2x1 plus x2 less than or equal to 600. So any point lies on or below this line satisfies the constraint 2x1 plus x2 less than or equal to 600. Anyway, the third constraint is x1 comma x2 greater than or equal to 0. These are non-negative constraints, always lies in the first quadrant. See, this is the first quadrant. So always they lie here. So this is the region, this is the solution space, this is the feasible region. This is the intersection of these two lines. See, the first line and the second line. So this is the point. So this is the intersection line. You can see the shaded region of both the lines. So this is called as the space of solution space or region of feasible solution. So see here clearly that, see here clearly you can see this is the first line and this is the second line. So this is the solution space. Okay, so the point A, E and D are the points of this feasible region. So the point E, how we will get, this is the intersection of these two lines. So by solving these two equations you will get this point. So now our problem is to find the point in which the feasible region which maximizes the profit. So our problem is to find the point in the feasible region which maximizes the profit, that is objective function. So to find the point E, solve the two equations, x1 plus x2 is 450 and 2x1 plus x2 equal to 600 by using any method, elimination or substitution, what you learned before. So just solve these equations, you will get the point E. That is, what is the point E? You are getting 150 is x1 and 300 is x2. So write it here. This is the point. Now write these points of A, E and D in the objective function, that is z equal to 3x1 plus 4x2. So where you will get the maximum value, that will be the maximum profit. So you are getting at that point the maximum value, where we have to find that point in the feasible region where it lies. So with the points A, D, E, the feasible region points, so substitute them in the objective function. So take first point A, that is 0, 450. So x is 0 and y is 450. So write in the objective function 3 into 0 plus 4 into 450. So the value is 1800. Like that, take the point D. This is x is 300 and 0. So you will get this answer, z equal to. So E, then substitute. You will get this answer. So this is x and this is y. So 3 into 150 plus 4 into 300. So when you substitute, you will get this answer. So these are the three answers. So where we are getting the maximum profit at which point? In the first point. If you write 0, 450, you are getting 1800. So the maximum value of z is rupees 1800 and it occurs at point A. So this is the answer for this question. So you are getting the maximum profit at vertex actually A. Okay, this is the solution. Like this you have to draw and solve the question.